Okay, this is a number 13. The question is about comparing the atomic radius for different atoms. And the first one is arsenic, and this is right here. And oxygen, need to find it here. And the bromine, which is right here. So the way that this one works out is as you move from top row to the bottom row from this direction, there is a increase in the atomic radius. So atomic radius becomes larger going this way. And when you move from the left to right, this is actually making this one atomic radius smaller, going the left to right. So comparing that, these two will be larger, but among these two choices, this will be the largest, and the bromine will be the second largest. So therefore, the answer for this will be arsenic becomes the largest, oxygen becomes the smallest, and this will be the bromine in the middle. So E is the answer. So this is a question number 14, also regarding the use of periodic table. So now they pick on the atom nitrogen, and which is located here. And the nitrogen itself will have an electronic configuration as a helium, and then there will be two S's. There are two of them, and then this will be 2p. There are three of them. 2p, three of them. So it will be 2s2, 2p3. So when they are in the neutral atomic state, they will have 5 electrons on top of the helium-like core. And the radius is defined by the essentially size of the electron cloud that is surrounding the nuclei. So therefore, we need to know what happened was when you go, as you add more 2 electrons, so this is from the add plus 2 electron more, 5 electron more, essentially this one, this radius getting larger, right? So this is going larger. But now you are going to strip off these 2 electrons, 3 electrons, and so on. So in the case of N plus, helium, 2s2, 2p2, so you still have a p electron, which looks like that, has that kind of character, and s electron looks like that. So this is an s electron, this is like a p orbital electron shape. Whereas the last case, which is you completely lost all the p orbital electrons, so you ended up getting this. So the size of this one is about just a s electron, 2 s electrons. So therefore, this will be the smallest. So the answer for this will be E. Okay, so this is number 15. Again, this is a question about ionization energy required to remove the electron, and we are using this notation of IE1, IE2. So it's energy required to remove the first electron is IE1, to remove the second electron is IE2, and IE3 is the third electron, and so on. So there are 6 of the numbers, and what you will notice that is this is really large. So I will write this way: IE6 is really large compared to IE1 to 5. So what that means is 6th electron removal is very, very difficult. So in that case, I will write this notation of saying that whatever the noble gas that you can choose, and plus there will be 5 electrons. So this is a case where you use all the 5 electrons. The last one, the 6th electron, is you need to take out from the noble gases. So what that means is your column number should be on the 5th column, which is located on here. So which one is on this, the 5th column? The P, the phosphorus, is the one. So the answer for this is C.